Okay, this is the lesson in which we start talking about functional groups. Right, so this is just an introduction to all the different types of functional groups and what exactly does it mean. Right, so a functional group is something you add on to your regular alkane molecule, which in some way changes the way the molecule functions. Right, and so some of the common things that we can add in are oxygen atoms, nitrogen atoms, and sometimes halogen atoms, which I'll show you in a moment. And by adding those different molecules or different atoms of different polarity, right, we can create different groups on the alkane molecules, which then change the way it behaves, right? Changes the properties. So that's why we call them functional groups, right? So if we start just from what we already know, we know alkanes, straight carbon chains or branched carbon chains, so just carbon and hydrogen, right? What can we do with those, right? Well, we can start adding in multiple bonds between the carbons. So all single bonds is what we call alkanes, right? And if we start adding double bonds between the carbons, we just change the suffix from alkane to alkene. And if we start adding triple bonds between carbons, we change the suffix from alkane or alkene to alkyne with a Y. Okay? So there's two new functionalities added into our alkane groups, right? So I mentioned that we could also talk about adding halogens. So this one's relatively easy. If we just attach any halogen, chlorine is pretty common, bromine is also common, right? Then all we actually form is a haloalkane, right? So we just sticking the prefix halo in front of alkane to signify that we have a halogen attached to our alkane. Right? Now, the majority of other functional groups that we're going to talk about are based on oxygen and nitrogen. Right? So the first two I want to talk about, right, are actually I find it easy to organize if we talk about them being related to water. Right? So what's water? Water is H2O. It has an oxygen with two hydrogens attached to it. Right? So what can we do to water? Right? Well, since we're talking about organic compounds, we can add a carbon chain to it. So if we just take one of the hydrogens, right, and we replace one of the hydrogens with a carbon chain, right? Now we have a carbon chain on one side and an OH, right, attached to the carbon chain on the end. This is what we'd call an alcohol. Right, so alcohols have this OH functional group, right, attached to a carbon chain. Okay, this is water. And then we could further add to this, right? If we took another water molecule, right, rather than just replacing one of the hydrogens in water with a carbon chain, why don't we replace both hydrogens with a carbon chain, right? So we have carbon chains on both sides. So if you have an oxygen, right, which joins two carbon chains together, right, that's no longer an alcohol. We now call that an ether. Right, so we've already got now a few functional groups that we know the names of, right? We have alkanes, which are just single bonded carbons and hydrogens, right? Alkenes include double bonds, alkynes include triple bonds. Haloalkanes have halogens on them, right? And then the ones related to water are alcohols, which only have one carbon chain with an OH, or ethers, which have two carbon chains on either side of an oxygen, right? Now we can do the same kind of thing using ammonia, right? Which is kind of like water. It's just oxygen with hydrogens bonded to it. Ammonia is just a nitrogen with hydrogens bonded to it. So we can just start adding carbon chains to ammonia, right? Now the nice thing is, when we do this, we don't get different names, right? We can add one carbon chain and we'll have two H's, right? Or we can add two carbon chains and just have one H, right? Or we can replace all three H's with carbon chains. Right? And like I said, the nice thing about this is that the name doesn't actually differ for all of these. These are all called amines. Right? The difference is, depending on how many carbon chains you attach to your nitrogen, right? This is what we call a first degree or primary amine. Then this would be a second degree or secondary amine. And this would be a third degree or tertiary amine. Right? But we call them all amines if it's carbon chains attached to a nitrogen. Right? Now, as we know, oxygen is able to form two bonds. So what if we make both bonds to a carbon, right? Well, the simplest form of this would be carbon double bonded to oxygen and two hydrogens on either side. And this would probably be the familiar name formaldehyde, right? Or the IUPAC name would actually be using meth for one carbon, methanal. We put al at the end for aldehyde, right? So if we start from this, we can do the same kind of thing, right? If it has two H's, it's just methanal or formaldehyde, right? It's only one molecule, so it just gets that one name. But we can attach different size carbon chains to one side of it, and it's still considered an aldehyde. So this is an aldehyde, the simplest aldehyde with just one carbon, right? But if we extend the carbon chain along one side, we get an aldehyde. And just like we were doing before, we can put carbon chains on both sides. So if we put our carbon chain on one side and we have a carbon chain on the other side, right? We call that a ketone. And so now we've got a bunch of double bonded oxygen compounds, aldehydes and ketones, right? Now, we could now go ahead and also put in a second oxygen on the same carbon. So that's what I've got down here, right? One double bonded oxygen, just like in aldehydes and ketones, but then also attached to the same carbon is another oxygen, right? And so if you have this COOH functional group, right? This is what we call an acid, right? Where this is the acidic hydrogen. So this is the hydrogen that can come off and form H+, right? And so this is what we call carboxylic acids. So carboxylic acids, right, have an acidic H attached to an oxygen, right? And then of course on the other side of this carbon, you can have any type of carbon chain you want coming off. So this OOH is your carboxylic acid group, right? Now of course, being an acid, it can lose its hydrogen. And we learned from Bronsted theory that if you lose your H+, you get what's called a conjugate base. So if I take the H+ off, I'm left with just this O-. Because I've removed a plus charge, I'm left with a minus charge, right? So the conjugate base of a carboxylic acid, right, is given a different suffix. It's called, it's given the suffix O8, and that's how the naming for the next functional group is named. So if we remove that H and we put instead carbon group instead of an H, just like we did before, took away an H, put away a carbon group, right? Took away an H, put in a carbon group, right? You get that acid group, except instead of now having an acidic proton, so it's not really an acid anymore, it has a carbon group attached. That's what we call an ester. And the way we name esters, which we'll learn later, right, is actually based on how we name the conjugate base of the carboxylic acid, right? And then finally, instead of bonding an oxygen to this carbon, where we have a double bonded oxygen, we could instead bond a nitrogen to the carbon with double bonded oxygen. And so this group right, with carbon double bonded to oxygen and a nitrogen on it, right? And that nitrogen could be bonded to H's, right? Or it could be bonded to one carbon chain, or it could be bonded to two carbon chains. It doesn't matter. We name them all as not amines, but amides. So I think that covers the full breadth of functional groups, right? And I like to like I said, I like to organize it this way, right? So you can actually see that there isn't really a huge variety of different things. It's more that there's sets of things that are all related to each other. So water, alcohol, and ethers are all kind of related to each other. You just keep adding more carbon chains to go from water to alcohol to ether. Amines are all related to each other, and that ammonia, first degree, second degree, and third degree amines are all related to each other, again, by adding different amounts of carbon chains, right? And then aldehydes and ketones are related to each other because aldehyde has one carbon chain or no carbon chains if it's from aldehyde, or ketones have two carbon chains on either side, right? And then finally, carboxylic acids, esters, and amides are all kind of related to each other because you have a double bonded oxygen with another oxygen, and if there's just an H, it's a carboxylic acid. If it's attached to a carbon, it's an ester, and if instead of an oxygen we have a nitrogen, it's an amide. Okay? So it helps to kind of organize it, I find. So now we're gonna, in the next several lessons, we're gonna start talking about how we name each of the different functional groups now that we know what the functional groups are.